Electrical power, AC, and DC electricity. There's 2 lectures today, so I'm going to go fairly quickly. Hit the pause button if you need to. What do DC and AC stand for? Well, DC is direct current, and it comes from batteries. And DC is like, I need to get paper from an office far away. I have a whole row of people, a whole circle of people, and I have each one pick up paper, and I have them walk it all the way down, drop it off, and then come all the way back. So that's what DC is like, where we're making a continuous circuit, and the electrons are what are making the circuit. AC stands for alternating current. And it comes from a power plant. It's got to be generated on a large scale. It can also be generated on a small scale with a motor. It comes from rotating magnets, which are usually done in a power plant. But again, you could do it in a motor. And the analogy for that one is if I have the people standing in the large circle, again, we've got to close the circle. Rather than each person running down, they just hand it the paper from person to person to person to person who drops it off. And then we actually still have all these people who are not actually carrying any paper around, but they're standing in a circle because you have to close a loop. So that's how I always explain alternating current and direct current. Direct current actually sending electrons around, alternating current pushing one electron into the next, which is much more efficient, works better over long distance. So, brief review. Current is the flow of charge. Sometimes we say it's the flow of power. It's measured in amps. Voltage is electric pressure. It's measured in volts. It forces things to flow. And I didn't want to say charge because then it confuses with the previous one. Resistance is impeding electricity, and it's slowing electricity down either just because it's getting in the way or because it's using it to do something, like run a light bulb. It has resistance. So, and now a new one. We briefly talked about it. What is electrical power? We call it P, and it's the current times the volts. And it has a unit of watts. Watts are also, if you recall from a long time ago, joules per second. So we actually use this typically because we have our light bulbs, old light bulbs with the curly Q, and they're measured in watts. It's a 100-watt light bulb. It means it uses 100 joules of energy every second. There's a fair amount. And again, that's what power is for. So as I just said, we calculate it simply. If I told you the current was 0.2 amps and the voltage was 4 volts, power would just be 0.2 times 4 is 0.8 watts, which we could also label as 0.8 joules per second. We typically won't do that. So AC power is almost everything in your house. How do you pay for electricity? Well, they actually measure it in kilowatt hours. Because you use so much, measuring in watts would give you a really huge number. And they don't want to just measure how many watts they use. They want to know how often you use it. So it's kilowatt hours. A kilowatt, 1 kilowatt is 1,000 watts, which is 1,000 joules per second. And an hour has 3,600 seconds. So 1 kilowatt hour would be like 1,000 joules per second, which is a watt, times 1 hour. And now we have to convert this. 1 hour has 3,600 seconds. Now we get rid of hours and we get rid of seconds. So 1 kilowatt hour is 3,600,000 joules. A lot of energy. And we're not going to talk about generating power. Just going to move on. But that calculation is tricky, so I'm just going to bring it down here. 1 kilowatt hour equals 3,600,000 joules. Just to give you a rough idea. If you're out riding your bike for a half hour, you probably use like a couple thousand joules of energy. Just to let you know how efficient our electric power is in this country. We can generate so much energy and use so much of it, and it makes our lives a lot better. So, jumping ahead to current and energy, we've talked about this. How does electricity flow? The atoms trade electrons. All right, so they go from atom to atom when a voltage is applied. So where do the atoms come from? Well, that takes us back, which we've done this already, so I'll be very brief. We need a model of the atom. We have all these electrons flying around. They're negatively charged, and inside this tiny little nucleus we have protons and neutrons. And then the electrons are the ones flying around the outside. Most of the mass, almost all the mass, is in the nucleus, and then the electrons just fly around the outside. The thing to remember is that the nucleus is positively charged, and the electrons are negatively charged. And the electrons want to come flying in and crash into the nucleus, but instead they're zooming around so fast, just like the planets in the solar system, that they don't. So that's what keeps the electrons from flying off, the electromagnetic attraction. So, all right, in the nucleus, I'll draw it bigger, we have positive protons and neutral neutrons. No charge. So why don't the protons take off? Because this is an incredibly strong charge. They do not want to be together. Well, I believe scientists couldn't explain this, so they call it a strong nuclear force in the nucleus. So yeah, there's some really strong force that keeps them together. And they really don't know anything about it. They'll say they do and stuff like that, but just remember they're lying through their teeth. It's one of the fundamental forces in nature, like gravity, like we already talked about it, the electromagnetic force. Negative attracts positive, negative repels negative, positive repels negative. And I just talked about it, the strong nuclear force, which is hilarious when you think about it. And then there's, of course, because we have a strong one, we have to have a weak nuclear force. What this is sometimes nuclei break down just naturally. They just start falling to pieces. So they overpower the strong nuclear force, I guess. So, and like I said, this is nonsense. It's just a model. Hence the reason we start the year talking about models and theories and scientific laws and stuff like that. That's their model, and it works. It works very well. It explains everything. It just seems a little odd. So not everything in the universe has to make sense. So a couple last little things. What's a coulomb? It's flowing charge. And how do we calculate it? Well, coulombs are amps times seconds. An amp is 1 coulomb per 1 second. That's what amps are, flowing through the wire. So if you have 2 amps flowing for 20 seconds, the charge would be 2 amps times 20 seconds equals 40 coulombs. That's it. Notice they're both C. Very annoying. Coulombs and charge are the same thing. That's it. Simple math. Lots to absorb here. Go do some problems. Good luck.